So I think we're
that moving?
probably good to get started soon. Welcome everybody to the inaugural Open Game Data Open Office Hours session. We're hoping to make this a regular thing about every 2 weeks. We were saying kind of the first and third Wednesday of every month is kind of the plan. And just to give you some background on what these are. So Dave Gagnon at Field Day Labs, University of Wisconsin-Madison. I am Erik Harpstead at Carnegie Mellon, by the way. We've been chatting about game data related problems and projects on a semi-regular basis for like 3-4 years now. And that's led into this project that we're also doing with Magy, Seif, El-Nasr, UC Santa Cruz, to try and put together a community of people that do research about humans, about education, about lots of different stuff, using data from games, data around games, and particularly how we manage a lot of the different interesting data science challenges that come from the complexities of games. And our hope is we can build that group up, and eventually we're looking to build sort of a broader set of infrastructure and best practices to help us understand how to do this better. And so one of the things that we're hoping to do with these sessions is kind of collect sort of best practices, example cases, and sort of interesting insights from how to do this kind of work. And so if you're interested in joining us, we have a Slack channel, which hopefully Dave can drop an invite link to in the chat. And that's where we will be sort of organizing these things going forward. And also, if you have a project that you would like to present on potentially in one of the future sessions, let us know. You can reach out to me. We can do that. But so to give you some primer on what these sessions are going to be like. So these sessions are kind of inspired by a thing that used to happen at Carnegie Mellon's Statistical Education Research Group, where somebody would come and present a project, and they would only give like a short intro primer to whatever they were doing at the time. Essentially like, here's what I've done, here's what I think it means, and stuff like that. And a statistics faculty would be there, and they would essentially just like workshop with each other as if it was like a one-on-one office hour session, but they would do it in public where everybody else could just watch, ask additional clarifying questions. And so essentially it's like a masterclass by worked example, is kind of the idea. And so our goal here is that somebody will be presenting a project relevant to some kind of game data, and the rest of us can workshop with them to help them understand what might be going on, what they might try next, what seems interesting, where they might go. The breadth of where this could roam is pretty open, so we will see if we can wrangle it. But today we'll be joined by someone from Field Day Games, and I would call you out if you weren't on an owl cam. But if you want to potentially introduce yourself and what's going on, and then we can get started from there.
Yeah, thanks, Erik. Hold up, we got some feedback here. Okay, cool. Yeah, so I'm Zach. I'm one of the data science interns at Field Day, and for the past 2 or 3 months, we've been working on this AquaLab validation study, where we've been taking these measures of external assessment, these tests that we gave to middle school students in schools and multiple samples, and then we're looking at game data for AquaLab gameplay and trying to create models to predict that assessment. So I'm going to share my screen here. Okay, yeah. All right, cool. Yeah, so generally we're looking at these tests that were administered in 2022 to these groups of middle school students who were asked to play AquaLab for 2 weeks. And then we're looking at their sort of success on this external assessment score. The score was measuring their scientific reasoning ability in these areas of experimentation, argumentation, and modeling. In the notebook attached, you can see what some of those specific sort of prompts and questions may look like. We're sort of asking them to connect sort of these cause and effect instances of patterns and relationships and ecosystems and habitat, sort of similar to what we see in the Wake AquaLab game. and sort of trying to use these implicit measures of knowledge, generally their performance in AquaLab, to predict what they got on this external assessment. And it's important to clarify here that this test is also a pre-assessment, not a post-assessment. So we aren't doing anything related to how they're learning from the game or any kind of pre-test, post-test, although there is a related study to that. This is just looking at, can we assess a student's scientific ability prior to the game from their gameplay data. So for those who don't know, Wake Tales from the AquaLab is a field day game that was released that involves this non-linear progression through a series of jobs. Students and players can choose the jobs that they want to complete, which sort of involves collecting data from a variety of aquatic ecosystems, coral reefs, as well as a variety of Arctic and other ecosystems. And then they're going to collect data. They're going to have to model that data, figure out how organisms are interacting with each other, measuring populations, pH, and other qualities, and then trying to present their findings and connecting all of these different facts and measurements to an assortment of scientists and argue certain relationships in the ecosystems that they have found. So experimentation is one of the scientific measures that we are looking at. And this sort of involves them going out and then finding data on organisms, on the pH or the quality of the oceanic environment that they're in. And then they are going to observe these organisms and the interactions between them and then collect facts on those interactions. Modeling is our second scientific assessment, and this is sort of involving them actually drawing connections between the experimentation data that they found, seeing how all these different organisms connect to each other in the ecosystem, as well as how the environment affects those organisms and vice versa. You can see here that we're looking at these organisms that the student has found in the ecosystem, and then they're seeing how, for example, the cyanobacteria is affected by the CO2 and the pH, and drawing connections there. And then our final measure of assessment is argumentation. And argumentation involves then taking these facts from modeling and experimentation and then returning to a scientist in the game who is asking them to draw some final conclusion, to reach some finding, and they're having to use the facts that they've collected out in the ecosystem in their submarine about all of these different qualities in the environment to reach some final conclusion and back that up with evidence. So in the game, these are sort of more implicit measures. We don't have an actual explicit test, but we're looking at, can they connect sort of these different factors in the environment together? Can they find these factors in the environment? Can they argue about their findings to this scientist and support their conclusions? So the pretest exam had assessment questions on these three categories. We had individual, experimentation, modeling, argumentation scores, and then the sum score. And then students had a 2-week window for gameplay in this case. And then these involved written responses that were manually scored by a separate team, and then those scores were provided to us. So these are our distributions of the scores here. We can see experimentation, modeling relatively normal, and then argumentation. So argumentation, the scoring was by far the most stringent. We see the least number of higher scores. And then modeling and experimentation, by far the most students succeeded in that category, and then modeling, relatively normal. And then for this assessment, we decided to bucket those scores generally around the median. So that is what that bucketing looks like here. And then I'll get into why we did that in a second. So our features that we're primarily using for argumentation are job tries in argument, job argumentation success ratio, and job argumentation fails. So these jobs involve the student presenting these facts they found to the scientists and then connecting facts together. So they generally have to do a sort of cause and effect relationship, such as this pattern appears in the ecosystem and here's why. And then if they fail to successfully argue that cause and effect relationship, the scientist will ask them to try and argue that relationship again. So we can see that sort of job tries in the argument measures general interactions with the screen. It's somewhat of a misnomer, but that's measuring from the beginning of the argumentation stage to the end. How many interactions are they making with the interface? Success ratio measures the number of accepted facts against the total facts that they tried to argue during that stage. And then fails measures rejected facts. So for this analysis, we decided to use a logistic regression model and treat this as a classification problem where we're trying to predict successes versus failures. Previously with the validation study, there had been some attempts to treat this sort of as a regression where we're just using like a multiple linear regression predicting a 1, 2 to 3 to 4. But we saw this as more of like an ordinal 1 versus 2 versus 3 versus 4, and decided to split at the median there to predict a student who is getting a good score on this assessment versus a bad score. So we'll be constructing a logistic regression model with all of these features, and it is worth noting that these are per job features, which means that for each of the 40 to 50 jobs in the game, there will be a different instance of each of these features that is aggregated. So there is a different, for job 1, job 2, job 3, a different job tries in argument score for each user that is aggregated. And then we'll be applying regularization, scaling, because we have some features in the 0 to infinity, some in the 0 to 1 range. And then we'll be using recursive feature elimination to try and select the best features for that model. So this is the readout that we're getting. One I may have forgotten to mention is job argumentation no reject, which is when a student perfectly completes an argumentation stage without having any facts rejected. So here we can see sort of the coefficients, p-values, and the pseudo r-squared for this readout here. And we can come back to this shortly. And then we're going to do a model evaluation here. So in our matrix, we get true negatives being predicted with 94%, true positives being predicted with 72%, an AUC of 0.86. And then we ran some k-fold cross-validation, found an overall accuracy of 0.78, because obviously across those seeds, we see some different readouts there. So generally the issue was trying to find features that can accurately predict those true positives, just because of the relatively sparse number of actual positive outcomes in the data set that we see, right? Where we see relatively few users for each job actually successfully attempting and then completing that job. Given that the gameplay sort of layout is not linear, users can generally do whatever jobs they want in a variety of different orders and outcomes. So we have somewhat imbalanced data set with many more zeros for any given job than ones. And then for the modeling category, the features that we are looking at are model export count, model predict count, modeling help per difficulty, and modeling interacts. So per difficulty was another kind of aggregate type that we looked at, where instead of aggregating by job, we are aggregating by the difficulty level of the job that the user is attempting. So each job was in the game was manually sort of assessed and assigned a difficulty level. So certain jobs, the argumentation or the modeling that the student is being asked to complete is much more difficult than others. So that lies for argumentation on a scale of 0 to 4. For modeling, that lies on a scale of or should I say 1 to 4 and 1 to 5. So these measure interactions with the modeling interface as they are attempting to draw connections between these different organisms, these different factors in the environment, predict those connections. Modeling help measures the number of times that they ask for help during the course of the modeling stage. Modeling help per difficulty is that same feature, but aggregated. And then modeling interacts is sort of a general feature that just measures interactions with the modeling interface all interactions over the course of that stage as they're drawing these connections. So this is our logistic regression readout for the modeling prediction. These are the features that the model has selected for use. And we can come back to this as well as we return for individual questions to sort of look at that. And then our readout for that model, much worse prediction for true negatives, but much better prediction for true positives. And we've spent a lot less time, I will say, on the modeling prediction than argumentation prediction. Modeling prediction just started this week. But it's interesting in that this is sort of the opposite problem, it seems, of what we have with argumentation, not because of any difference in the data set imbalance, but just because these features seem to be much better at predicting positives than negatives. We have an AUC score of 0.74 and a K-fold cross-validation score across multiple different segments of that trained test data of 0.71. So we haven't yet constructed a model to predict experimentation, which could potentially be more difficult as we see experimentation sort of skewed where most students are getting a good outcome on that, which may be because that stage of the process involves generally less sort of synthesis where they're connecting these different elements of what they've found together. Experimentation more so involves going out and actually observing what's happening. They can look at multiple instances of things and they're not necessarily needing to actually like draw a cause and effect or draw a relationship together. But yeah, I mean, now I'd really like to, I guess, sort of hear from you guys and your input. So it's worth noting that all of this testing was done with a trained test split on one population. So this was a single sample of students in the summer of 2022. We've since collected another sample and ran the same experiment. This time we also did a post-test. That is not relevant for this assessment or this sort of experiment. And then I believe there's also a third sample that we are collecting in the future, correct? Yep. Yeah. Okay. Yeah. So some things with that, it's interesting to see, right, modeling and argumentation, the differences in how we're able to predict those positive and negative outcomes. Sort of from the talk that we had with Erik and Magy when they came to Madison several weeks ago, it was interesting to see how we can sort of use visualization to see user patterns and behaviors. I'd be interested to see if there's any potential for that here and seeing if we can find patterns in, good outcomes versus bad outcomes in these modeling and argumentation stages. And then, yeah, there will be some replication and testing that eventually happens in that second and third sample. So that's a general overview of this experiment. And now I guess this is our first time doing this. Do we just open it up to the floor? Yep.
So some general housekeeping. There's a bunch of people here. If you could please use the raise hand feature, just because I don't want to make this a super cacophonous Zoom room. So yeah, really interesting. And what I want to do is pair it back to you, my understanding of what I think you're doing. Let me know where I'm wrong, okay? So sounds like what you're trying to do here is you have some pre-tests for 3 constructs: modeling, experimentation, and argumentation. And you have some gameplay before, like behavior metrics, and you're essentially trying to predict a binned pretest score given gameplay behavior.
Yes.
Okay, great. Can you go back to like one of your, well, so I guess I have a couple of things that I would have sort of first questions for is, so maybe the first one, help me understand kind of the logic of the binning.
Yeah, definitely.
And not so much like how it works, but why you did it is really more my question, because a thing I often see with people binning scores is like you're essentially blowing away a lot of resolution that you already had in the original data. And so why do that?
Yeah. So we had spent a lot of time before with this sort of linear regression model that we had been using. And then we switched eventually to an ordinal logistic regression. So predicting 1, 2, or 3, and 4 in that instance. But with that, we saw an issue with a relatively smaller number of samples for any given one of those scores. We also saw sort of a strange anomaly and sometimes increases in scores from to a 3, but then maybe a decrease to a 4. And then, yeah, sort of the way the survey was constructed. So sort of in our talks with Stefan at UPenn, and then Sherry, right, about how the survey was constructed. And Luke, I don't know if you can speak to this at all with how we talked about like how the argument score is actually assessed there.
Yeah, should we switch back to the?
Oh, turning this on? Yeah.
So now that we're out of presentation mode and back into open discussion mode, we'll go back to the owl here. Yeah, so I think one of the things that came up in discussing how that assessment tool was constructed is like that this wasn't a super formal assessment. This isn't like a standardized test where the exact score is like the exact perfect thing. It was a thing that I think that Sherry constructed, and we think it's a good little assessment, but we weren't necessarily concerned with, are you a 2 or a 3? And rather we were concerned, do you generally know how to do argumentation, or do you generally not know how to do argumentation? We're not at a point where we're looking to predict with great precision, exactly what you get on this particular test, because this particular test may or may not be that good at giving you, this is exactly how good you are at.
Am I correct there that the granular or sort of the way the assessment was structured was sort of like a binary 0 or 1 for several individual questions?
Yeah, that's a good point as well.
Yeah.
The individual questions were, I think with 1 or 2 exceptions, there were individual questions and you either got a 0, you failed on this question, or a 1, you succeeded on this question.
And then is the score essentially like a total?
And then that's just a total across 3 questions.
Do you have the individual item data?
Yeah.
So you could do logistic regressions of the individual items if you wanted to.
Sure.
But that's maybe getting into psychometrics you're not interested in. It's not your assessment necessarily. But so then the median, it's just a straight median split?
For modeling, yes. For argumentation, the median for argumentation was a 1, as you can see from the skew. So we adjusted that by we bumped that up 1. So for argumentation, we're calling a failure a 0 or a 1, and a success a 2, 3, and 4.
Okay. And so modeling, that's a straight median split?
Yeah.
Of what looks like to be a basically normal curve?
Yeah.
I wonder if one thing you might consider, which would get a little messier, but particularly because modeling is so normal, like it feels a little weird to split a normal curve in half arbitrarily. So something that you'll sometimes see is people will take like upper third, bottom third, and not use the middle. So can you tell a good person apart from a bad person? And if you don't really trust where the middle of your scale is, you at least know the people on the extremes are probably on the extremes. Because I wonder if part of it is like you're kind of making an arbitrary choice of what side you flip in, particularly when you have like a bell curve like that. And maybe you're just kind of modeling noise rather than modeling a real thing. And so you might try to look at whether or not it's important to be like in the upper third or the bottom third. Again, you'd be running into kind of a smaller data problem, but might be useful.
The other thing I'll mention, a little bit of like theoretical justification on this, where it was sort of a happy circumstance that it worked out this way. I think I had things flipped when I mentioned how those scores happened. I think most questions were actually 0, 1, 2, and there were a couple exceptions that were 0, 1. So with that said, for argumentation score, it was 2 questions and you got a 0, 1, or 2. So if you scored a 0 or 1, that means that that you bombed at least 1 question. Modeling a 0, 1, 2 would mean again that you bombed at least 1 question, modulo that there was 1, 0, 1 in there. But so these roughly correspond to a negative outcome being you bombed at least 1 of the questions, which would be reasonable evidence you didn't really know what you were talking about. You didn't understand this particular aspect of scientific thought that well.
David?
Yeah, I think one of the things that when you raise that question too, that comes up that I'd love to get some input on is that the use of this really is kind of twofold. Like the original, like why we would want to model for this. So the first one is from like a learning engineering standpoint. We want to deploy this game to millions of kids. I think we've already had 100,000 kids play it, and we can't afford and we can't feasibly put out this assessment for all those kids. So we want to be able to make a way to have a pretty darn good guess at how they would have done if we could give those hundreds of thousands of kids this assessment. And the reason we want to do that is so that we can A/B test a bunch of stuff, right? We want to try to intervene in different ways that gets that score up. So effectively, we're looking for a success metric. And success in games is complicated, and we've got like 3 other ways of approaching it right now. 2 other ways of approaching it right now that go beyond, did you make it really far in the game, which isn't a really useful thing, or are you obedient to the goals that we gave you in the game? So that's like use case number 1. And then use case number 2 that comes up for potential future research is, can we give a real-time indication to a teacher in a classroom that is watching a bunch of kids, looking over shoulders and say, hey, can we give you a warning that this kid might, be showing some signs of trouble, that go beyond, again, use like whether they're progressing rapidly in a game. So we're saying like, are they going to bomb the test, like down the road, potentially days from now? Are we seeing early signals that they are really missing it? So that one's a little farther off. So that might factor into that question of, why we would bin, or why we want, like what the resolution of the score is that we want out of it. Because it's really those 2 use cases, I think, in the end of the day. So I'd be curious how other people are thinking about that kind of context.
And so if other people have thoughts, feel free to raise your hand. You could just hang out and watch, or you can contribute if you want to. I had some other possible follow-ups that I would look into. So can you go to one of the regression tables? Doesn't really matter which one. And this is kind of more of like this is both of thinking about like thinking about some of what Dave was just talking about, of like, what do you want to be using this for on a practical level, or if you're thinking about potentially trying to publish something like this. I would look at a table like this and be like, what do you think this means? And I think particularly what I find interesting is it cuts across a bunch of jobs kind of randomly about whether or not like you got this one totally right, or you did this one better than not, or whatever. Is there something about these individual jobs that is relevant? Is it like digging into the level design and thinking about this level like really hits this skill, or if you get another 100,000 kids run this again, are you going to get different coefficients that are?
Yeah. I guess it would have been nice to have a formal sort of readout of job names and assessment difficulties. In most cases, the argumentation or modeling difficulty is at least above a 3 in most cases. For I'd say around 60% of jobs, it's above a 3, especially with modeling. Like I believe 42 is the Bayou job, and that has a modeling difficulty of a 4. And we see that with most of these, and that there's a general alignment in the features that are being chosen and the assessed difficulties of the jobs that those features correspond to.
And this is just a straight logistic regression of all these features?
Yeah.
You might consider like a more hierarchical model, or because like you have this notion, you have this construct of job difficulty that doesn't actually appear in this model. It implicitly is modeled by labeling these jobs differently. But really it's like, is your model export count on a difficult job important rather than your model export count on job 42, whatever job 42 is. And I wonder if you, and it depends a bit on how many students do you have, or how many playthroughs is this?
It looks like 169
Yeah.
number of observations. At least that's what went into, or is this?
Yeah, I believe it's around. It was around
Yeah,
150
right.
to 200 for all the samples.
Yeah.
Yeah.
And one bit of context we can add to, like, just to the original question of like why these jobs. This particular project has gone through a couple of shifts in like what was the goal here. So a couple months ago, the wording that we had was something to the effect of, can we identify key moments in the game that are predictive of a player's understanding of these 3 concepts? And so I think part of this sort of orientation to per job is an artifact of that, where a lot of our earlier analysis was, let's use feature selection, modeling approaches to identify the jobs where some aspect of that job helps to predict this thing, so that we can analyze what is it about those jobs that led to them being predictive of this outcome. And so I think with this shift away from that and more towards let's like predict general success to general failure, I think it's totally fair to point out that orienting all of our features towards job by job by job is a lot less relevant. But context-wise, that's kind of where we arrived at this point. Yeah, I think we'll look into sort of modeling things directly based off of difficulty. I think that would be an interesting direction to go.
Magy?
Yeah, I have a very different question. I think the question about how to trigger things so that teachers can kind of look into what the student is doing. I'm wondering how much of work you've done with teachers in terms of like showing them some of the data and seeing how they want to see the data. In my kind of work, and most of the time the teachers want to see process, want to see what the student is doing, not like completely all the different students. But I'm wondering what if you've done any kind of studies with teachers to see how they want to interpret and look at the data.
Yeah, so I can speak to that a little bit because I had a project that was all about that a couple of years back, where we put together for a different game, not for this game specifically. We did basically a dashboard as an in-classroom tool during gameplay facilitation, as gameplay is happening, to help teachers understand where is a student at within this game. I don't know, like specifically within that, what to talk about here. We put out a paper at Meaningful Play this last time that Meaningful Play ran, and definitely be happy to share it. From what I remember, I think, we found a lot of interest in understanding like where in the game are you, and then also trying to identify specific like sort of specific failure or versus and specific success. Like if a student was really struggling and was showing evidence of struggle or spinning their wheels at one point, that was something that teachers were interested in seeing. On the other hand, if they were doing something really successful, like if they had identified a key strategy for success within that particular game, that was something teachers were really interested so that they could go and sort of debrief around how did you, discover that this was an optimal way to, progress here. And so like those were some of the insights that came out of there. Yeah, as far as like how this analysis fits in, I think it's not clear to me if this specific like predicting what you would have gotten on an assessment is sort of a during gameplay, like that it would fit into what teachers are looking to do. But I think the idea here is maybe to look at it more as, okay, after 2 weeks of gameplay is done, like what can we tell you sort of retroactively about how things went for your students, which is a thing that in that project that we had before, we had teachers bring up broadly the idea that it would be interesting to have some way of looking back, sort of cumulatively on gameplay. But that wasn't something that we've had a chance to follow up yet on or to dig in into more detail there as far as what that way of looking at gameplay data as a teacher, would be what kinds of things we want to see. Does that answer the question? That's the closest project that we've had to, what you were asking about.
Yeah, it does, because I'm trying to think of like how would you use the current like method that you're like the binning and the scoring that you're doing to kind of indicate things in gameplay, which I feel like maybe not the right approach for particular students, but for the cumulative approach, I can see ways to kind of think about cumulatively how people are scoring and then retroactively look at the gameplay.
Yeah, I think it's worth noting here too that this is just an active question I think we've got after doing that pilot. Like, can we use real-time analysis in classrooms for these big complicated games? So that project was, a good pilot run for, working out a co-design process with teachers and creating some prototypes and trying some things out. But I know the next ones that we're proposing right now have a little bit of a focus around culturally sustaining pedagogies and trying to think about detecting things like linguistic struggles or opportunities that are existing that the teachers don't already have a way to perceive. So it's kind of like for teachers that don't know how to see something within their classroom, like can we augment and kind of partner with them to expand their perception, basically, right? So like these models running behind the scenes can give them some early indicators to, potentially be looking for some things that they couldn't see just looking over a shoulder. But yeah, future research, right? It's like set the stage for where we could go with this to help teachers facilitate. The one thing we have heard from so many teachers is it's so hard to know how kids are doing in the game. Like it's just so hard to know. And if you're spending, days and days on the game, you've got some moments to, intervene and ask. But if it's just one class session, it's like, what do I do? Like, how can I help out? It's hard to know. Have you done dashboard work, by the way, Magy? For like I know you've done some reporting kind of stuff for esports related stuff, but have you done anything like similar to those?
In what context? In the context of schools?
Yeah.
No, we have engaged with teachers, but it was all more informal education, not in the classroom. And most of the time we're looking at process-oriented approaches rather than like cumulative scoring.
Yeah.
And with process-oriented approaches, it's easier because they can see the process of every student rather than seeing what has happened with all students. Like, because I think students struggle in different ways, and I think that's the idea, is to figure out where do students have problems, and individually, and that's how we were approaching it, but not really aggregating over classrooms.
Yeah.
Yeah, I think thinking about the real-time question, which I know we've done a little bit of like playing with modeling for doing that in other games that you guys have. You're probably going to need some different. You're probably going to be you're fundamentally predicting a different thing, so you'll need a different measurement of that thing. Like if you're going to be predicting like students dropping out or like failing a test. Like right now you have, are you above or below medium of a test, not necessarily are you failing. If you're going to define median as passing, I guess, then you can say that. But whether or not the teacher would use median as passing, which we very rarely do in education, would be a thing to think about. And so then you're maybe like picking out you're probably predicting a minority class or a majority class, kind of depends on how difficult the assessment is. And the kind of what you expect the base rate of like student failure, for example, should be or would be. And that would be what you could use. Probably at least you could start with a similar kind of approach and probably start a similar kind of prediction. But keeping in mind that if you want to be doing it for real time, you're probably predicting something different. Another challenge we ran into when playing around with some real time stuff in other field day games is in this, and I think this is probably, we were talking about like dropout or disengagement or something. You can't really use like whole session data to predict partway through session dropout, because that just if they're dropping out, you won't have the rest of the session. Like if you're trying to do a thing in real time, you can't really use the future necessarily. And so that would be something to think about as well.
I'd really love to hear from folks where you think we should or could take this next.
Just a quick question. Is there a parallel between the scores and the concepts that they're learning? So I know that there is that modeling argument and experiment. I was wondering if there are like subcategories of what the concepts are that they are learning that you could think about, like doing a little bit more diagnostic of where people are scoring in terms of high or low for these concepts. So like in a cumulative effort, you can just say that some percentage of students are basically getting that concept, but not getting that concept from the scoring.
Yeah, I can say that. So those assessments are process-oriented assessments. They're really thinking, how do you do these different kind of fundamental skills of like making a model? And the way the assessments are structured is that they have another scientific problem that people are having to talk about how they would solve it. So I know one of them is about plants and the design of an experiment to try to figure out, what's influencing how rapidly a plant will grow. So it's got a little illustration and it says there's 3 conditions. And then the question to the student, on the assessment is like, so what could we know from this experiment? So it's really about the process of experimental design or the process of modeling or the process of arguing. And the subcomponents of those is in the grading rubric, but it doesn't directly match to the game in like a really meaningful way, because the game is coming at those process questions pretty differently than you would in these other environments. So there is a mismatch, I think, there, where the way the game is thinking about those different subcomponents isn't, we didn't take like an evidence-centered approach, you know, from the root and saying like, we want to make sure that it directly lines up. We definitely took more of a, let's build an experience, well, that's even possible to build and is fun. Like
But-
fundamentally, yeah. Yeah.
But you do have a skill map for the game, right? Like people progress through these different things. Maybe they're not aligned with the progress from the learning curriculum perspective, but they maybe the game has its own progression. And so maybe you could
Yeah.
do the scoring on that, and then it would be like they knew this they couldn't go from an experimental design with like 3 variables to like 5, that kind of thing, or something like that. So that it would be more diagnostic from the teacher's perspective of where students struggle.
Yeah, that's
Yeah.
exactly right. And the thing that that does exist there for sure is coded in terms of those difficulties of each of these jobs. And it is things like, can you go from 1 variable to 2, you know, versus 3? Or when you're arguing, can you, you know, synthesize multiple different sources of information at the same time versus just responding to a prove this kind of interaction. The thing that complicates that, though, which is keeping us busy with analysis, is that not only do you have the progression of the practices of science, like the process, how do you do it? But then it's intersecting with all the new content that you're actually doing that on, where we're introducing new ecosystems and new relationships between the members of the ecosystem. And so we got another year or so of just trying to detangle, you know, that multi-dimensional science.
But you have that annotation across each of the jobs and stuff, like where you could do, like, one thing I was going to suggest, kind of like getting into like knowledge component modeling, which is an EDM technique, educational data mining technique. Like, instead of this being like model export of job 4, what if it was model export skill, which I don't know if you consider that a skill, of my first job, of my second job, because I also know like they don't necessarily do the jobs in order, right?
That's right.
And so rather than like right now, this is organized in terms of the structure of the game, but if it was instead organized in the structure of a player's experience, you might see some different relationships, particularly if you're looking for learning. I think relating it to a external measure might end up being a little less important, but because that's another thing, is like you're assuming players are learning from playing your game while also trying to make it an assessment. And so you're trying to make an assessment out of a thing where the ability underlying that assessment is fundamentally supposed to be changing.
Yeah, I mean, this is a fundamental learning in
Yeah.
games problem, right? Is like we're segmenting the data to say this segment of time is an assessment, and then some things happen, and then this segment of time is an assessment, and learning is, did they get better, you know, over. So here we're kind of saying, let's assume that learning isn't happening, and instead look at the whole experience as a signal. And we're kind of taking that approach, where obviously an evolution of this would be to move back and say, well, let's look at the first 5 jobs you do versus something that happens later. Let me see if I can say something back to you, I'm really curious about too. So we've got the, and kind of synthesizing what you and Magy said. I know we've got the rubric we used to determine how complicated a given job was. And at the end of the day, we just gave it a numerical score of that's a difficulty level 3. So it's kind of like a theoretical difficulty that we're, imposing on it. That's informed by a bunch of learning progressions theory. So we've got that like imposed thing. But what I heard Magy say that's interesting would be, and actually you with knowledge components too, what if we pull that thing apart and instead code each of the jobs and by just the bits of the rubric with a bunch of 0s and 1s, was this skill required or present here? And it's just in the rubric we have, not summed together, but as an individual probably a Boolean, I think, for most of those.
Mhm.
And use those as the way of saying, yeah, it's more of just like a classic, like, what do you call it, learning curve kind of approach.
Mhm.
For each time that you encountered an opportunity to give evidence that you had this certain concept, you know, how did you do?
Yeah, so that would be like a learning curve analysis,
Yeah.
KC modeling approach. And and you could even start to deal with some of that entanglement you had of like, there's the practices of science, and then there's the domain content. You can just tag those as multiple knowledge components on an individual opportunity. It becomes a kind of a gnarly roll up process, but there are tools that exist in the EDM community to do that for you. To make sure everything's tagged correctly before you throw it at a regression model. But that might be interesting to see, because essentially you're looking at like the difficulty of a given step is due to sort of a mixture of different skills required to deal with it. And that might be my developing science skill. It might be my appreciation of otters. It might be the fact that I'm not looking at my screen right now, and that one you can't really model. So like there's always going to be some amount of noise, but that might be something to think about. And then towards this, essentially what you're claiming here, what this model is attempting to claim, is that these features are a measure of the, in this particular model, the modeling skill. And so what about them is the prediction, is the predictor of the modeling skill. And there might be some sort of further breaking apart or disaggregation you could do.
I think that's exactly it. It's like part of this assumption of what Zach worked on is, are there signals inside of this that can help us predict this other thing kind of at a high level? And then it feels like one of the next move, given this approach, is how well can we describe why those signals are interesting, which is different than the pure evidence-centered approach, right? Which would be saying we're going to think about assessment first and we're going to design an experience to do that. This is not that. You know, this was definitely, we're going to design an experience that we feel like elicits a certain kind of emotion and, you know, passion, excitement in kids, and get that working first. And then retroactively see what power it has for assessment.
Anybody else have questions, comments, thoughts?
Erik, with that hierarchical approach you were talking about, is that, are you saying like a different kind of model, like a decision tree or something, or just a different approach to like the
Yeah, I was vaguely suggesting like a hierarchical regression model instead of a straight logistic regression. I'd have to think a little bit more about exactly how you'd want to structure that hierarchy. But like a thing that I often do when I do similar sorts of models for some of my own work is I'll often chuck the level in as a random effect, like the level indicator, and then I'll usually be modeling on like kind of this KC approach of what are the practices or what are the other features I care about. And then like I know some amount of noise that I would throw into a random effect is due to the fact that every level has different level design. And that's a way to kind of factor it out without necessarily caring about it so much. And so right now you're kind of, everything's a big fixed effect in a giant model that you're like down selecting. And you could potentially be a little more sort of thrifty with your degrees of freedom, essentially, and get closer to the model that you actually think exists. So,
cool.
If that makes sense. Yeah. I don't know if 169 students is enough necessarily. So, it's hard to do power analysis with hierarchical models. You basically have to do it through simulation.
That's the big thing I'm seeing, right out of the gate, is we're throwing so many features at this model for the size of the data that we've got these assessments for.
Yeah, how many? So how many features is 3 features per level or per job, right? And there's how many jobs? There's at least 43.
Yeah, so it's
So that's
around
like
130
Yeah.
ish.
so it's like almost as many features as you have data points,
Yeah,
and then it's being run through a downsampler.
yeah. I'm surprised it does as well as it does.
But one thing I would look at, which I've done with some of my own modeling sometimes, is like grab a random other subset of like your 169 students, like because you ran it again, right? You get like a couple thousand students a week, right? I don't know necessarily on Wake. I don't know if Wake's that popular yet, but if you were to run this again with a completely independent sample, would you get the same coefficients here or not? Because if the completely different sample would end up with the conclusion of very different features, then there's not really like stability in your across data sets. And that would be something I would worry about if I cared about interpreting the coefficients. If all I cared about was prediction, I would maybe be a little less worried. But if you care about what it means, not just what it can tell you, then
I think that's something that we'll plan on doing with that new data set that we've got that we just collected at the end of this last school year. Yeah, if we take that fresh data set from the second iteration of this pre-test gameplay, post-test implementation, yeah, be curious to see, yeah, if the jobs that show up are stable, if we get similar coefficients, and so forth.
and then if you do, that's when you really start being, what is it about job 10? Like,
Yeah, that's right.
That's when you really start digging into the level design and seeing like, why does this matter so much? All right. So one question we have generally about these sessions is exactly how long should they be? I think officially our plan is they're only about an hour, so we are right about at the end of the hour. I have personally booked out an hour and a half for my own time, but I know Magy has to leave soon, and Dave also probably has to go. Yeah, so we're very curious and would love any feedback, privately, publicly, whatever, about how you think this session went or these sessions could go, things you think could be better. We are working on a better solution to getting people a calendar invite that automatically puts itself in your time zone. I know I had to deal with that with a few people. But yeah, once again, if you want to join us on our Slack community, where we are going to be sort of tracking both this and then also larger projects to try to build this community of game data people. I'm just going to reiterate some links for people that might have joined late. And then next week, let me find the link for that. So part of the forcing function to get these things started was we are going to be hosting a session exactly like this in 2 weeks, but co-organized with the Kai-Play conference, which is a conference on human-computer interaction in games. So the format is exactly the same, but the Zoom link will be different, and you have to RSVP. So I just put a link into the chat for you to RSVP. You will be sent a Zoom link the morning of the Eastern time zone morning, the US Eastern time zone morning of the session to join. The format will be basically the same. It'll be a little bit longer because we'll probably do a little bit of more formal preamble of what the Open Game Data Project is. But we'll be talking about another field day game, which I don't know if Dave, you want to do a bit of a teaser on what that is.
Yeah, so that one is taking a really different approach. So the idea there is we've got a game that's called Headlines in High Water, and it was recently released to the public, and we've got a little bit of development money left. So now that we've seen, thousands of people play the game, we want to test a bunch of assumptions that the design team had with how people would interact with it, how people would succeed, and how people would fail, and where they would get stuck, and basically use data collected from a public audience to highlight how that development team should spend their remaining budget, what changes they should make that are going to be the most value for them. So we're going to have one of the designers there, the producer of the project, Sarah Gagnon, and then we're going to be presenting on what we've learned from analysis, and then really kind of modeling that interchange between data and design.
All right, so you can look forward to that. We'll talk about that more. And then our plan is the schedule is essentially every 2 weeks, every first and third Wednesday of every month. We'll have another one of these sessions back on this Zoom link. We will make sure that calendar invites and everything are nice and clear going forward. If you have a project you would like to present on, could be about anything as long as it's game data adjacent. A lot of our projects will probably have a bit of an education bias, but you don't have to talk about education. You talk about anything. Let us know, and we're happy to slot you into the schedule in a session time that works for you. And other than that, thanks for joining us, and looking forward to seeing everybody.
Yeah, see you on Slack. That's great.
We will be posting these recordings on the calendar, on the schedule after the fact. I think we're probably going to run them through a bit of an editing so that you don't have to see a bunch of the pre-talk. But the recordings will be made available. The data from projects are available when shareable, and we're going to be building up sort of a corpus with that. So. All right.
Cool. Thanks for facilitating. See you all around.